let us continue. So my screen is visible to all of you. The screen is visible. Yes.
Yes, sir.
So basically, we are discussing about image enhancement. Okay. In the image enhancement, we discussed they are broadly classified into two categories. One is your special domain enhancement. Second one is your frequency domain enhancement. देन हम लोगों ने पढ़ा था स्पेशल डोमेन एस्पेक्ट में आपका तीन टाइप होते हैं. फर्स्ट इज योर पॉइंट ऑपरेशन, basically where we perform all the transform all the operation on basically particular point, and in this case the neighborhood point will not affect whatever enhancement that we perform in a particular point. Fine. Similarly, next type आता है मार्क्स ऑपरेशन. मार्क्स ऑपरेशन में क्या होता है, एक पर्टिकुलर पॉइंट का जो एनहांसमेंट करते हैं दैट विल नॉट ओनली डिपेंड अपॉन whatever we perform on that particular point, as well as it will depend upon its mass, or we can say its neighbor. Third one is the global operation. So the global operation say enhancement of each image depend upon every pixel that is present in your images. Okay, so there are three different categories we have studied. So on this basically we discuss about the point operation, then about what you understand by mass operation, and what you understand by the global operation. And we are discussing, if you remember, we are discussing the types of operations. Okay, basically types of point operation we are discussing. On which first category we have discussed how to improve the brightness of an image. Okay, how we can either increase or we can decrease the brightness of image. So it is basically done with a mathematical formula that can be used. Now, if f of mn is your original image, okay, then if g of mn is enhanced image, how we'll get? Simply we will add a constant value. Okay, now simply we will add a constant value to each of these original images, so that now this constant value basically represent your intensity level. Okay, what is our intensity level at that particular point. So we will add a particular intensity level so that we can improve the intensity of the images, or we can say the brightness of the images. Okay, this example we are already seen in the previous class. So this how we get it. Actually, the final image will be like this is my original image. So if I add each of this pixel value, okay, what we'll do? Each of this pixel value will be added with a you can say the constant values of 50. Okay, then we will get an enhanced image that will be represented in this manner. Fine. So till now we have discussed in the previous class. So today we will further continue. So next is how we can decrease the brightness of any images. It is similar to the just opposite to the how we are increasing the brightness of the images. So in this case, instead of adding the constant value, what will we do? We will subtract a constant value k here. So we can say the brightness of the image can be decreased by subtracting a constant k from all the pixels of the input image f of mn. So if I say this is my input image, now let us take this is my input image f of mn. Fine. Now this input image basically represented in digital format in a matrix format. Yes or no? Now each of this box will represent each pixel. Okay, each pixel. Suppose this is p1. Now how we can decrease the brightness of any images? Now I have to subtract a constant value k. Suppose a constant value k, I will subtract from each of this pixel. Okay, so from each of this pixel, that means I will subtract from this pixel. Okay, this is p1 minus k. Similarly, I will subtract from p2 minus k. Similarly, I subtract from p3 minus k. It means how we'll obtain a decreased brightness image by subtracting the constant value k from the original image. And that the formula for this one is given by this formula. Now this is your enhanced image, okay, which is decreasing brightness. Okay, decreasing brightness which is given by original image subtracted by the constant value k. That means each of this pixel value will be subtracted with the k value. Fine. Now, what we are doing now, we are performing on a particular point here. Remember, the neighborhood points are not affecting this one. So what we are doing, if you are subtracting this particular pixel with a value k, that only will be changes. But its neighborhood pixel is not responsible for changing of its particular pixel value. Fine. Now you can see in this example, now this is my original image. Okay. It is very much brightness, which are having the very much brighter or very brightness. Okay. Now when we subtract a value k, now here we are taken k value equal to 70. Okay. We are assumed that k value is equal to 70. So we have subtracted the value 70 from this particular image. Okay. So when we have subtracted the particular value 7, now this is my obtained image. Now this is your g of mn. Okay. Now this is my f of mn. So how it is particularly happen? Now this basically this image is obtained from. So what I will do for g of mn, that means each coordinate of this particular image will be obtained by subtracting f of mn, that means each coordinate f of mn minus of 70. Okay. Fine. So how we will obtain this one? So basically we are subtracting constant value from this one. So this is the first type of operation, okay, where we can add we can enhance the brightness, or we can decrease the brightness of any images. Okay, simply we can add a constant value. That constant value is particularly nothing but the intensity level of each pixel. Fine. So let's move on to the second operation. Okay, how we can adjust the contrast of the image. Okay, the second operation or second point operation is, this is the second type of point operation that we are performing, which is your contrast adjustment. How we can going to adjust the contrast. Now it is very similar to the what we have studied for brightness. Now here what we will do, we will basically perform a scaling on all the pixels. Okay, contrast adjustment is done by scaling all the pixel of the image by a constant k. So this is a mathematical formula that is given. So what we will do, so instead of adding the number, what we will do, so what we will do, we will multiply with the constant value. So whenever we multiply with the constant value with each of this pixel, okay, with each of this pixel, which basically enhance, or we can say contrast, the contrast of the images will be enhanced. Okay. Now changing the context of the image changes the range of the luminous value present in the images. Basically, changing the contrast of the images means changing the range of luminous value that is present in my images. Okay, this is the second type of operation that we are performing. Now, third type of operation that we are performing on a point operation, okay, is on histogram manipulation. Okay. Now, histogram manipulation is very important because we have to represent an image in a histogram format, and sometimes we need to equalize that histogram. Okay. So basically, the histogram manipulation basically modify the histogram of an input image so as to improve the visual quality of the image. Basically, what we will do, so we will have an image. Okay. So this is my image. Okay, actual image f of mn. Now what we will do, so we will represent this in a histogram format. Histogram format basically represent, it is a graphical representation of an image. I can say histogram representation is nothing but a graphical representation of the image. Okay, where it is in the form of bar chart, where every that bar will be represented as an intensity. How many pixels are having that particular intensity level? Okay, suppose I say this is 10. Okay, the intensity level of 0 equal to 10. That means there are 10 pixels. Okay, there are 10 in my entire image. There are 10 pixels which is having an intensity level of 10. Suppose I intensity level of 15. Suppose there is a 5 pixel. Now there is a 5 pixel which is having the intensity level of 15. Now this is a histogram representation or histograph representation of the particular image. So basically, whenever we represent in a histogram format, sometimes we need to perform a manipulation like equalization of histogram, okay, so that the visualization of the images can be improved. Fine. So histogram manipulation basically modify the histogram. So whatever histogram that we have designed for a particular image, okay, or for the input image, so that we can improve the visual quality of the images. The only reason of the manipulation behind the histogram is to improve the visual quality of an images. And the basic idea about the histogram of an image. Okay, so what is the basic idea behind that? What was the basic idea behind of representation of histogram? The basic idea about the histogram of an image, or we can say histogram equalization technique, is used to improve the visual quality of the images. Okay, so main reason that we have basically one of the major technique we are applying, that is histogram equalization. Okay, so first of all, we will represent this image in a histogram format. Then we will apply a histogram equalization method. Why we are applying this histogram equalization method? Because to improve the visual quality of the images. So whenever you need to improve the visual quality of the images, so we will go for the histogram equalization method. Okay, so first of all, let's understand what you mean by the histogram. So we can say histogram of an image is nothing but is a graph or a plot of a number of occurrence of gray level in the image against the gray level value. So as I say, the histogram is nothing but a graph, or I can say it is a plot. Okay, so how will plot this graph? Now suppose I'm having an image of 300 cross 300. Okay, suppose I'm having a 300 cross 300 image. Now how many pixels are there? Total number of pixels are there, 900. So what I will do, first of all, I will divide this entire pixel into different ranges. Okay, ranges of gray level. Okay, I know that the gray level will be 0 to how much? 225. So what I will do, I will divide this entire pixels, this 900 pixels, into different gray level. Then I will start plotting the images. That means, suppose I given a range of 0 to 10. Okay, so I've taken the first range 0 to 10. So I will see how many pixels are present or how many pixels will lie in the range of 0 to 10. Suppose this is my range. Suppose there is 20 pixels which is lying in between the range of 0 to 10. Similarly, second range will be 10 to 20. Fine. Now I will see how many particular pixels are lying. Suppose there is a 30 pixels are lying here. Similarly, I will range from 30, like this, up to 255, or what is the maximum range of gray level. Fine. Similarly, we'll draw. Now, finally, what we will get? We will get the plot in terms of a bar graph. In terms of bar graph, where each of this bar represent number of pixel. Okay, or we can say number of occurrence of gray level in an image against the gray level values. Fine. So this is a particular, we can say histogram is nothing but a graph which provides your number of occurrence of each pixels of a gray level values. And this is, remember this one, the histogram provides a convenient summary of an intensity of the image. So what this is particularly representing, so we can clearly understand by this histogram how many, or we can say the intensity level of the images can be studied here. Okay, so if you want to study the intensity level of the images, that means what was the range, what are the particular, what the maximum number of pixels that is belonging to particular intensity level. So we can easily analyze from this one, okay, from this graph. But one of the problem is that, okay, it is very unable to convey any information regarding the spatial relationship between the pixels. So one of the problem is that, so no doubt you will get the information from the histogram. We will get the information about the intensity level of the images. But one of the problem is that we will not get any information regarding the spatial relationship between the pixels. Fine. So next point about the histogram, if you remember, the histogram provides more insight about the image, contrast and brightness. So basically, whenever you want to improve the contrast or brightness of the images, we will go for the histogram representation. For example, we can say the histogram of a dark image will be clustered toward the lower gray level. Okay, if the image is having low contrast and low brightness, so what will happen? So we can know that this is a very dark image, then all your pixels will be clustered towards the low gray level. That means it will be clustered towards the zero. Now this will be clustered like this. Okay, the number of pixels that is having the black uh, low gray level. That means 0 to somewhat around 20 or 30 will be clustered more number of pixels. Okay. Similarly, if the histogram of the bright image, if we take a brighter image, or we can say higher contrast and high brightness image, then it will be going to cluster towards the higher gray level. Okay. If it is a much brighter level or brighter image, now what will happen in this case? Your histogram will be going to what? Going to cluster towards the brighter light, because the particularly when we are representing the histogram, we are representing in terms of their intensity level. Okay, so let me show the example how we will represent. So let me complete this slide. I will show you how we will represent the histogram. So next point you have to remember about the histogram is, for a low contrast image, the histogram will not spread equally. That is, the histogram will be narrow. Now, if it is a low contrast image, now all this pixel, all this your bar of the histogram will be not spreaded equally. There will be unequal representation of this images. And for high contrast images, okay, the histogram have an equal spread in gray level. Now, if it is a high contrast image, then on that case, your histogram will be spread in equal manner. Okay. Now, why we need histogram manipulation? Now, for as I already said, for better visualization or uh, for measure modification or visualization of image, we will go for the histogram equalization method. Now, equalization is a process that attempts to spread out gray level in an image so that they are evenly distributed across the range. So, what we will do? So, we will try to spread, okay, try to spread all this number of occurrence of the gray level in a equally distributed range, so that the we can say once we are equally distributing, okay, equally distributing or evenly distributing this histogram representation, now it will be neither in a high contrast manner, neither in a low contrast manner. That means we neither cluster at the low level gray, or not it will cluster at the high level gray. So it will be equally spread. Okay. Now histogram equalization rises the brightness of the pixel based on the image histogram. Now, if it is a very dark image, now it will be improve the brightness of the image. If it is very brighter image, now it will be decrease the brightness of the images. Second thing, remember histogram equalization technique, where the histogram of the resultant image is as flat as possible. Then histogram equalization provide more visual result across the wider range of images. Okay. Now the question rises, how we can equalize the histogram. Okay. Now this is a particular method. Okay. These are the steps that you have to follow. Okay, or the procedure for histogram equalization. So how we can equalize the histogram. Now the image is given. From the image, we can easily convert this image to the histogram. Now the difficulty comes here, how we can equalize this histogram. The histogram equalization is done by the following step. Step number 1. First of all, we have to find the running sum of the histogram value. Then we will normalize the value of from the step 1 by dividing the total number of pixels. Then we multiply the value, okay, obtained by the step 2 by the maximum gray level value and round it off. Then map the gray level value of the result from step 3 using 1 to corresponding. Okay, so let me explain this with an example. Okay, so let me solve an example. It will be very much clear to you. So how we are converting the histogram and how we are performing histogram equalization. Okay, so they may ask a numerical here. So they may give an histogram. Okay, and they may ask to equalize the histogram. Okay. Yeah. Yes. So this is the question given. Okay. Now you can see here the question given. So what is the question? Now perform the histogram equalization on the given image. Now this is our image given. Okay. The basically this is 1, 2, 3, 4, 5. 5 plus 5 matrix representing the image. Now this is the intensity level. You can say the intensity level of an image. Okay. So first of all, what you have to do, you have to form this particular matrix. First of all, find the what is my maximum range here. Okay. So what we will do now, what we will do first of all, I will find the maximum. Let me show you the histogram. So first of all, let me draw the histogram for this one. Suppose you want to draw the histogram for this one. Now I will take the values. There is no 0, no 1, no 2, then 3, 4, and 5. Okay. Then I will take a value 3, then 4, and 5. I have to count the number of times the 3's occur. Now 3's occur how many times? 1, 2, 3. Now there is no 3, 4, 5, 6. Now 6 times. Suppose this is I will take 2, 4, and 6. Now this will be 3 is appearing how many times? 6 times. Okay, similarly 4, how many times 4 is appear? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now 4 is appearing 14 times. You right? 8, 10, 13, 14. It will be like somewhere like this. Okay. Now this is appearing 14 times. This is appearing 6 times, 20. Now 5 is appearing how many times? 1, 2, 3, 4, 5 times. Now 5 is appearing 5 times. Now this will be your something histogram representation. If I represent this graph, okay, represent this image in the histogram, it will be represented like this. But this is not in equalized manner. Now what you have to do now, I have to equalize this histogram. Equalize means now you can see somewhere it will draw like this. If it is smaller, then it is larger, then it is smaller again. Okay, so somewhere we have to normalize. Basically, equalize means we have to normalize such that it will be distributed uniformly. Okay, histogram equalization means now we have to distribute these values such that eventually it will be distributed or uniformly it will be distributed. So how we can perform this one? So first of all, the very first step, we have to find the maximum intensity of this particular pixel. So what is the maximum intensity here? So you can see here the maximum intensity is your 5. Okay, then we need the minimum. So as we know that now, if with the maximum intensity is 5, what is the minimum number of bit I require? The minimum number of bit which is required is 3. Yes or no? Because 2 to the power of 3, what will happen? 2 to the power of 3 is 8. Okay, so I can represent 0 to range of 7. है कि नहीं? अगर अगर हम लोग 3 बिट यूज करेंगे ना, मैक्सिमम इंटेंसिटी क्या था यहाँ पर? मैक्सिमम इंटेंसिटी था 5. To represent 5, minimum कितना चाहिए? If I use 1 bit, so what I can represent? I can represent only 0 to 1, range of 0 to 1. If I use 2 bit, so I can only represent 4, that means 0 to 3. So if I use 3 bit, okay, how many bit I require? I require 3 bit, so I can represent 0 to 7. So now 3 bit is sufficient. Now 3 bit is sufficient to represent, because the maximum value is 5, so I can represent 0 to 7. So 3 bit is sufficient to represent that number. Because what happened? Because there is what are possible levels are here, ranges from 0 to 5. So for 3 bit I can represent 0 to 7. Now if I represent the histogram representation, now you can see what representation. Now this is your histogram representation. Okay, now I divided the grayscale level, which is your 0 to 7. देखो 0 to 7 हो गया आपका grayscale level, और number of pixel हम लोगों ने assign कर दिया. पर 0 के लिए कुछ भी नहीं है, इसलिए 0 लिखा है. Then 1 के लिए कुछ भी नहीं है, इसलिए 0. 2 के लिए भी नहीं है, 0. For 3, how many times 3s are there? 6 times. How many times 4s are there? 14 times. How many times 5s are there? 5 times. 6 कितने बार है? 0 times. 7 कितने बार है? 0 times. So if you plot this one, if you plot this graph, okay, about this is your number of pixels, or I can say this is my number of pixels, and this is your gray level. So you will get the graph something like this. This is called, first of all, histogram graph representation. Fine. The first step, what you have to do? First, you have to find the maximum value of a given image. Then try to find the number of bits that is you require. Okay, how many bits that we require to represent that histogram. Okay, so once we are able to find the number of bits, then we will go for plotting of histogram. Okay, or we compute the particular histogram. Then the next step is your very first step, which will compute the running sum of the histogram value. So what do you understand by running sum? Running sum is you will add cumulative values. Okay, or running sum is you will find the cumulative value of the histogram matrix. Okay, now I will add running sum here. Now first of all it is 0, it will be 0. Now 0 again it is 0. 0 plus 0, it is 0. Now it will be 6. How it is obtained 6? It is nothing but for value 3 there will be 6, and before that how much is that? 0 is that. So 0 plus 6, 6. Now how is 20? So before that how many is that? Cumulative. We are finding a cumulative. Before that there is a 6 plus 14, which is 20. Now this is your 20 plus 5 is 25. Now 25 plus 0 again is 25, then again is 25. So first of all you have to find the cumulative frequency or running sum of the histogram. Then what you have to do? So once you find the running sum of the histogram, then we will divide the running sum obtained by step 1. That means total number of pixels. In this case, total number of pixels is 25. You can see how many pixels are, because it's 5 plus 5. So what we have to do? The running sum that is obtained. Okay, what is running sum here? Running sum is 25. So I have to divide by total number of pixels. So it will be 0 by 25. It will be 0 25, 0 by 25. It will be 6 by 25. It is 20 by 25, 25 by 25, 25 by 25, 25 by 25. So what we have done, whatever the running sum we are obtained, that is divided by total number of pixels. Okay, now step number 3, if you remember what we have to do, now I have to multiply the result obtained in step 2. So now what is the result we obtained here? Now we multiply with the maximum gray level. So what is the maximum gray level here? The maximum grade level is 7. So what I have to do, I have to multiply each one of them with 7. Okay, step number 3. So what I have to do, now what I will do, so let me do this one. So what I will do, yes, so what I will do, so I will multiply, okay, I will multiply all the above. What we have, first of all, we calculate this step number 1, we are calculating running sum. Then the running sum is divided by the maximum number of pixel. Step number 2. Then step number 3, I am multiplying this step number 2 with the maximum real level, which is equal to 7. So I have multiplied 7 with all of the pixels. Okay. Then what you have to do, now whatever result you obtain, you have to round off. Okay. So whatever result we obtain, now we are going to round off. Now in this case, if you see here, so result obtained here is 0. Fine, no need. So I have round off to 0. Now result obtained here is 0. Round off to 0. Result obtained is 0. Round off to 0. Okay. Now what is the result obtained here? The result obtained will be, it is so 25, we can multiply this one, so it will be round off, okay, or we can say this is something, it will be 2 point something, so whatever you will get, it will round off. Now if you round off it will be intensity level 2. Now again, if you round off this one, you get intensity level 6. If you round off, you will get intensity level 7, intensity level 7, intensity level 7. Okay, so after multiplying, what you perform, you have to perform the round off. Then you have to round off to the closest integer. Okay, closest integer of the following. Now once you round off, now mapping will be done. Okay, now how you will perform the mapping? So this mapping is important. Okay, how you perform the mapping is very important here. How you perform? Now this is my original K level. Now this is what you obtained here. This is a histogram equalization level. ओके अगर पहले हम लोग देखे थे वहाँ पे क्या था, एक में 14 था, एक में आपका 5 था, एक में आपका 6 था, लेकिन अभी आप देखिए यहाँ पर 3 में कितना है, 2 है, 4 में कितना है, 6 है, 5 में 7 है, 6 में 7 है, 7 में 7 है. Now if I represent this matrix, now how the equalization will be done? Now how the equation will be done? So all 4s are converted to 6. So all 4s will are converted to 6. Okay. Then all 5 is converted to 7. Okay, all 5s are converted to 7. Then all 3s are converted to 2s. Okay, all 3s are converted to 2s. Fine. So this is your histogram representation. Now this is the, or we can say this is my histogram original image, and after equalization. Okay, after equalizing, what we are getting? Now we are getting in this form. Fine. So what they can ask in the question, so they will give an image for you. Okay, they will give an image. Okay, they will give an image. Image आपको दिया होगा. I have to calculate the histogram equalization for this image. How you perform? First of all, identify the maximum intensity level. Then choose the number of bits to represent it. Once you find the number of bits, find the histogram representation of itself. Okay, then find the cumulative frequency or running sum. Then multiply, divide by running sum with the maximum number of pixels, which is the total number of pixels. Then multiply by the maximum value of the pixels. Okay, when you multiply with the maximum value of the pixels, then round off to the closest integer. So once you round off the closest integer, you will get the histogram equalization. Then simply convert your original image to the equalization images. Fine. So this is something about how we are performing histogram equalization. And why we are performing? Because for modify the visualization representation of given event. Okay, if a given image is given, to modify its visualization. Basically, visualization means your brightness and contrast of the images. Okay, to modify the brightness and contrast of the images, we will go for the histogram equalization method. Fine. So hope it is clear to all of you. If you are having any doubt, you can ask me. Yes, if you are having any doubt. Okay, fine then. So